Happy Friday. Welcome to our Zoom call. We are going to be talking about some API token stuff because I will tell you sometimes I suck when it comes to environment variables and sticking API tokens where they need to be. So we have some special guests today. We have Calypso, first time on our live stream, and we've got Mark. Welcome back, Mark. Always a pleasure to have you. And hello to my amazing co-host Akansha. How are you all doing today?
Pretty good.
Doing great.
Doing great, yeah. Friday, end of the week.
Fantastic. Yeah, it's Friday. It's a good day. It's nice and sunny outside. We've got a nice weekend coming up. And we're gonna, dig into some of the API token stuff. And it all started with a tweet, right? It was a tweet that I think Tracy Lee, the person or the CEO of this dot labs, she retweeted your tweet around something around API tokens. And the first person that came to mind was Mark, right? Because Mark is a specialist when it comes to all of this. Anything with respect to certs, tokens, APIs, Mark is my go-to. So I figured, let me bring him into the conversation because he's going to provide the best roundabout answer or just details that we need to be able to move forward. I'm going to kick it off to you both because this is your conversation and I'm here to listen and learn.
Awesome. So, Calypso, why don't you tell us a little bit about what you're working on and what questions you got?
Yeah, so I tweeted out help for getting access to tokens because I'm really new to tech. I'm transitioning from theater into tech, and I'm currently an apprentice with this dot. So Tracy gave me like the kind of like the interview assessment that she would give out to people so that I can figure out what I need to work on and like if I'm able to maybe take on a couple coding projects. And as soon as I got into this project, I hit a wall because I have never dealt with bearer tokens ever before. And I was like, I've accessed APIs, but never one that asked me to get a token. And I was just very confused and could not figure it out. So I asked for help. And that's how I ended up here.
Awesome. Well, let's have some fun. So you had sent over a link for this movies API URL, and see if I know how to put this in the comment, or how do we splash that up on the screen, Marino? I don't know how to.
You just put it on the comment section, and I will like show it on the screen.
Like this? Does that work?
Yes, it does.
Ah, sweet. Okay, so we got this movies API, and the API comes in two flavors. The first is GraphQL, the other is REST. So I'm going to focus on the REST. REST API. That's the easiest to do, and it's the easiest to explain. So what's interesting about this API is when we first look at it, I want to share. Here, I'm going to present. I'm going to share. And here we go. I'm sharing now, right? Yep. Okay, cool. So here's the API. And let's go down to the README. So the first thing it says is here's the base URL. So this looks like...
Could you like zoom in a bit?
Yeah, good idea. It's a little more readable, I think.
Yeah.
Okay, cool. So the first thing it does is it tells you, hey, go get this token API. So let's talk a little bit about what a token is and what a RESTful token is. So a bearer token is a ticket to get into the game or a ticket to get into the show, right? Like, once upon a time, you got tickets for things that didn't have your name on it. You didn't have to log in to use it, right? You were given a piece of paper. And, that's the way we liked it. And, but that was what a bearer token is, right? Like, you have this piece of paper, and if you lose it, that's it, right? If somebody snatches it out of your hand and runs through the turnstile with it, and it gets torn, that's it. Like, that's it. You got nothing. Okay. And so the the big value of a bearer token is it's easy to distribute, right? It's not tied to anything in particular. When you're talking about complex networks where you've got multiple layers of infrastructure, it's a lot easier to pass through those layers because it doesn't get impacted by it. So, as an example, let's say you were going to make a call to this API using certificate authentication. So this is one I like to harp on. Certificate authentication, right? You would have a key and a certificate on your local machine, and that would try to establish what's called mutual TLS off to your API. You have to have a point-to-point connection with where that API is being validated. So that means it's like line of sight, basically, if you think about it that way, right? Like you can't see over the horizon with certificate-based authentication. But with token-based authentication, you just stick it in an envelope, send it in the mail, and it gets there, right? Or you put it in an email and you can print it out, or any other number of ways for that ticket to get there. The major downside to a bearer token is its upside, right? It's very flexible to move around, but that means it's also very easy to lose and very easy to get yourself in trouble, right? Because you can lose that token. There's also another interesting kind of point here that we'll look at is you have to authenticate to get the token somehow in general, but here you don't. Excuse me. So if we look here, it says to call the auth token endpoint. So what we're going to do is let's grab this URL. We're going to do auth token. And I'm not sharing the right one, so I'm going to stop, present, share screen. And Marina, have you talked to the folks at multiple? I mean, I thought you were, that was your job, right?
I've mentioned it several times to them. I'm going to go follow up with them soon.
So what I'm going to do is I'm going to curl. I know this is, or not curl, but I'm going to open this up. So here's the token.
Mhm.
So this token is what's called a JSON web token. JWT is what it's often short for. And a JSON web token is 3 parts. You have a header, which is a bunch of base64 encoded garbage right now. You have a payload, which is, this is the part that says, who are you? What are you going to have? So we're going to look at that a little bit. And then you have a signature. And so by taking those 3 pieces and a little bit of magic, we can validate what this JWT is. So I'm going to copy this JWT. Let's take a look at what it is. So I'm just going to go to jwt.io. So this is a great tool for taking a look at JWTs and seeing what's behind the curtain. So we're going to paste it in. Now, I will say that, remember, this is a bearer token, which means you never share it with anybody. Like, I mean, this is a silly API that we're having fun with, so it's not that big of a deal. But when you're talking about like the enterprise world or any kind of like production API, once you have that token, you protect that thing with your life. Because if somebody else gets a handle on it, that's it. So things that you want to be careful of with JWTs, logging. If you log a token, your logs are now a vector to lose that token. Environment variables, right? People will often just dump environment variables, but if you've got a JWT in your environment variable, now you've just exported your JWT. Anytime, again, think of it like a physical key. What would you not want to do with a physical key? Hiding it under the doormat maybe isn't the best security idea in the world, right? So here's our JWT, and you can see that jwt.io does a really nice job of highlighting everything. And it's very small. There's not a lot of there right now. So our header has 2 components right now, HS256 and JWT. So the history behind JWT is it was originally created as a format to use with mobile applications that were really low bandwidth. And so they wanted to have as little extra content as necessary, which makes the naming infuriating because it's almost another language. So alg is algorithm, right? TYP is type, right? And the algorithm here is HS256. So when we talk about the way that JWTs get encoded, there's really two ways that you can go about it. One is using something called symmetric encryption, where you and I both agree to a passphrase, a key, and we have the same key. And so I can decrypt the token, you can encrypt the token, and vice versa. So what that tells us is that the token was encrypted with this key, but it doesn't tell us who did it, right? Because you have the key, I have the key. It also means that you had to securely get that key somewhere, which, I mean, that can be problematic, right? Like, yeah, am I sending it to you in the mail? Am I, emailing it to you? If I email it to you, then everybody has it. So you don't generally want to use symmetric cryptography when it comes to JWTs. What you want to use is asymmetric cryptography. So this idea that I have the private key, PKI, public key cryptography. I have the private key. Everybody has the public key, right? So you know that I'm the one who generated the encryption on this because I'm the only one who ever has the private key, at least in theory. Whereas you have the public key, so you can verify it, but you can't recreate it, right? You can't take that public key and say, oh, even though Mark generated this key, or this JOT, I'm going to make changes to it, re-encrypt it with the public key, and say Mark still generated it. It won't work. The math just won't math there. So typically when you look at what a JWT has, and I'll grab a JWT that's a lot more likely to be something you'll see in the real world here in a moment. But when you have that JWT, typically it'll be with symmetric, or asymmetric, cryptography. So the payload here is really simplistic. And the reason why is the movie API doesn't actually care who you are. They're using this because, quite frankly, they just want to stop somebody from spamming and denial of service their API, right? Like their API is behind, it looks like a Amazon API gateway. They just want to have something that makes it so that you actually want to talk to the API. You're not just hitting URLs just to cause mayhem with some automated script that you download from the internet. But in a real world situation, this is where we would find out, who are you? What's the point of all this, right? Like what do you have access to? So sub, which is short for subject, will say who you are. If you're a user logging in, what's your username? We'll see that these are called claims. So the parts in purple here, these are all called claims. You're claiming to have the subject OpenJWT0, right? I'm claiming to have the username MLBIA. And so that once the receiver of this token, what's often referred to as the relying party, gets this token and validates it, they are then going to say, oh, this is OpenJWT0. My policies have been written against it. So I've thrown a lot at you so far. Any questions? Anything? Yeah, I'm doing a bad job.
No. It's all good information.
It was just a funny story when you said that like we have to protect our token, because in my previous org we were working on an application, so everybody just used to share the bearer tokens with each other if their application wasn't up. So it was like so such a bad practice. But yeah.
We, you're breaking my heart. So let's take a look at. Can I? Oh, wait, right, wrong password. You can't see what I'm doing on the screen. I'm grabbing a jot from another screen. So, oh no, this is okay. Here we go. So let me grab another jot. That's a refresh token, ID token. Here we go. So I'm going to do something that you should never, ever, 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 ever do. Take a production token and put it in some web page. Not really production, but so this is a token from that would look more typical of what you'll see for production APIs.
Whoa.
So the first thing you'll see is that everything's bigger, right? Like there's just more information. There's just more. So let's take a look at what the header is. So there are more claims in the header. This time we're identifying a KID or a key ID. That's because APIs can issue multiple keys and can respect multiple keys. And then we also have our algorithm, which this time is RS-256, RSA 256. So you'll see RSA is common. Elliptic curve is another common one. If somebody on an interview asks you what's the difference between RSA and elliptic curve lets you have much stronger encryption with much smaller keys. The same amount of encryption that you get with a 1024-bit RSA key, you can get with a much smaller elliptic curve key, and it results in much smaller payloads. And then we get to the payload. We got a lot more stuff here, right? So the first one is the issuer. So this is who generated the token. Now, as the person who holds the token, this part actually really doesn't matter, right? Like, because this is just your ticket to get in. This is like the nonsense barcode at the bottom of the ticket, right? The paper ticket that you use to get into an event. You, as the holder, don't really care other than you're using it. But it's good to know what's in there, if only for debugging. And, when it doesn't work, what are the things to look at? So the first one here is the issuer. Who generated this token? And one of the things that's really important about this is that the issuer often has to line up with what the API is expecting, right? Because think about it. There was a big difference between this token and our last one, right? So my API is expecting it to be issued by this URL, right? I don't even want to look at it if it's issued by some other issuer, right? And we know that this is the actual issuer because we can verify the signature using the public key of the issuer. Okay. So what's happening here is that I, as a relying party that's accepting this token, can go to a special URL based on the issuer and download the public key. So the API is deriving a link of trust, a chain of custody, right? I, as the relying party, can go to that URL, get a special JSON document that has keys in it. That URL uses HTTPS, which includes this public key infrastructure. So someone said you can trust that this URL is who they say they are because it's been signed by a CA that I trust, a certificate authority I trust. So you're building off of multiple layers of security, most of which you as a developer don't really need to know. It's just I'm adding context to confuse everybody. Then you've got the audience. So this is who is expecting the token. Now, the audience is important because it lets you scope out who should accept it. So it'd be like, well, I got a ticket for the Yankees game at Ticketmaster, but I'm going to bring it over to the Kennedy Center to go see a show. They're both from Ticketmaster, so it'll work, right? And, you get to the theater, and they're like, this is for baseball. What's wrong with you? Now you get funny look, which is normal because I always get funny look. But, so scoping that audience makes it so that the receiver, the relying party of the token, knows off the bat, hey, I don't even want to bother. So like from a security standpoint, where this kind of becomes important, is making sure that you're giving permissions to things that it should have and not too much. So I want to say it was 2017, maybe 2018. Target had a massive breach of its point of sales, where they scan your credit cards. And a big problem was because their cleaning service had tokens that gave you access to the point of sale. Right? Like that's bad. That's not good. So that's where the audience comes in. These next so the next one is expiration time. So this is the number of seconds since the Unix epoch. So this is when you're looking at Unix-based systems, Linux, all of the commercial Unixes, many of them still exist anymore. There's probably some Solaris admins screaming at me right now. The zero for when they start counting time is like sometime in the 70s, like what, 1972 or something? And so that's the number of seconds since then that when this will expire. So that's a timestamp. We're going to skip JTI for now. IAT is when it was issued at. Again, these terrible abbreviations. So that's when it was issued. And then not before is when, don't accept this before now. So your range of how long this is good for is from not before until not after, or EXP, excuse me. And the reason for that is time is really hard to keep synchronized across systems, right? So like most, especially in the enterprise, we synchronize our time on a regular basis, but there's always a little bit of skew. So if you're going to have a really short-lived token that's only good for a minute, that minute might only be 30 seconds, 40 seconds, depending on how good your synchronization is. I know of at least one major implementation that I worked on where, and these are household names, where they had to set the clock skew to like an hour because there was nothing they could do to keep the clocks in sync, which is crazy to me, but that's what they did. So, I know you're new to tech. Have you ever heard the saying, it's always DNS? In the authentication world, if it's not DNS, it's often because of the clocks, and the clocks are off. So that's a really common issue is are the clocks off?
Okay.
So we didn't have these claims in the last in the original token, right? So how do you know it expires? The sad answer is it never expires. And so always be wary of tokens that don't have those expiration numbers in there, because that means unless you have some way of validating that token, it's good forever. So we've got the when it was created, who's it for, who generated it. Then we get into just a unique identifier. Like this is just used to say, oh, this token may have been used already, right? Like maybe in a replay attack or something. Next, we get into the claims that relate to who you are. And so we've got that sub again, M. Mosley, name, and then group, right? So this is just, these claims are just information to be used by the relying party to figure out, can you do what you say you want to do? Now, one really important thing is if you ever find yourself on the other side of this equation, you're writing a relying party and you want to validate tokens, the first rule of token validation is don't do it yourself. Ever, please, never, ever, ever, ever do token validation yourself. It is so easy to do wrong. And I'm an expert. I've been doing this for almost 30 years and I've done it wrong. Right? Like it's so easy to do. How easy is it to do this wrong? So you see this alg here where it says RS-256? You can say none in this in this spot, which means there's no encryption, and it's a valid JWT. And so if your library that you use or your process that you use to validate this JWT doesn't check to say, oh, if it says none, rejected immediately, you can actually find yourself accepting unencrypted JWTs, which means anybody can write them, right? So like that's one of the easy gotchas, but there's so many of them. Like just don't do it yourself. That's the first one. So we've talked a lot about what these bearer tokens are, what they look like, but again, you as the developer, you don't care about any of this other than potentially debugging, right? Like this is all just additional information.
Right.
Let's get back to where we started. Our token. How do you use this token? So the most common way to use a token with the RESTful API is in a header. So a HTTP header, when you type something into your browser, let's see if this actually pulls up. Is this gonna more tools, developer tools? Does this no? Let's see if I can move this. Can I? Try to see if there's a way I can move this back in. Do this. I used to know how to do this. Let's see. Can I do this? Share this tab instead. Oh, there we go. Okay. Can I?
Yeah.
Yes, and I can make it bigger. Okay. So what I'm going to do is I'm going to refresh this tab. And we're going to look at the token.
Yeah.
I'm going to make this bigger.
And response.
Here, can we make this like this? That's a little better. Okay. So here are what are called the request headers. So when your browser makes a request to anything, right, it really doesn't matter what it's talking to. It sends more information than just what you put in the URL bar, right? So there's the parts that you as a human see when you interact with your browser, right? You might put information in a form, whatever, right? That goes in. But then there are these things that go in to the actual API call. So the bits that go over the wire that are called headers. They're not visible to us as the browsers, as the people doing the work, or interacting with a web page, but they're part of the spec. They're part of the protocol, and they tell the API or the page or the web server all sorts of stuff. If you're into like privacy or anything, and they say, well, you can get thumbprinted pretty easily based off of this information. This is the stuff that they're talking about, where they take all this information, they say, well, actually, I know where you are, right? Like I know that you are, you can see I'm using a Mac and I'm running, I'm running Chrome, and based on all this information, I'm pretty confident I know that you're sitting in Virginia. It's crazy, but it's true. Uh, Once upon a time, excuse me. Remember Flash games back in the day?
Yeah.
So back in 20, when did I leave the firm? 2010, I think I left PwC. So about 2009, 2010, right about when banking websites were starting to get into the whole multi-factor authentication thing, where like if you wanted to, you could like call them up and they would send you an RSA token that you could use, or there were a couple of different schemes. Banks were really trying to get out of having to send you something physical to do MFA. And one of the ways that they were doing it was by thumbprinting your system. And they were doing it based on all of the headers that Flash would send in the HTTP request. Like, so a stupid amount of information gets stored. So from your standpoint, what's important is this is also how you send this token you just received to your API.
Mm.
So we've been having enough fun here. Let's actually share some code.
Mark, before you
Yeah.
share that, yeah. So Sudhanshu had a question like, should this be in a cookie with HTTP only and secure flags?
That is a great question. No. So cookies are a special type of header. So HTTP, when it was first designed, was a stateless protocol. You make a request, you get a response, that's it. Right? Like that's all there was. And then Netscape, and if you remember Netscape, it might be time to schedule a colonoscopy. Netscape said, okay, well, this isn't really useful, right? Like this is not very helpful. We need to be able to have state across these requests. So they came up with this idea of cookie, where a web server could tell the browser, hey, hold on to this little bit of information and send it back to me on every request. So the web server says, hey, this is Mark. Mark's ID is 1234. No, that is not the combination on my left. 1234. And every time Mark goes to another web page, tell me Mark's ID. So that way I know that this is Mark's session. Okay, so that's the point of a cookie, is for managing sessions.
Mm-hmm.
There is often a desire to use JWT as session cookies. They are not session cookies. They have too much information in them. They're often too big, to be honest. It doesn't take long to go over that 4K limit. They're not like it. The Venn diagram of what they're useful for is not two circles. There's overlap there, but it's not two circles. So what you would often do is you will say, okay, I will authenticate to a web application with a token, but then the web application will give me back a session and manage the session on its own. So that's the difference between a cookie and a header. Now, HTTP only, when your browser sends headers down to the web server, there are some flags that can be set on the header. I don't think any of these. This doesn't have any cookies. No. So you can tell the browser only send the cookie for HTTP requests, as an example, right? Because you can make more than HTTP requests in a browser these days. Only send the cookie if it's a secure connection, a TLS connection. So when you have a cookie that is HTTP only and secure, what you're telling the browser is this cookie you receive from the web server, the web application, is only for HTTP. You can't send it anything other than a web request, and it can only go over a secure connection, which is good. But that's for a session cookie. You should be using that for cookies, not for. You shouldn't be using JOT as cookies. So I hope that answered your question.
I didn't get the last word you said, John.
JOT,
I didn't
JWT.
get the. Oh, J.
Yeah, don't use JOT. Don't use JWTs, JSON Web Tokens, as
Okay.
session cookies. Use a hard to guess unique identifier that you then use to manage across your session. And encrypt that identifier is always a good idea too, to be able to validate it. But you don't want to use JOTs as cookies. So let's go.
Yeah.
Right. I know how to do this. I'm going to present, share screen. I do computers. Window. I think it's this one. Yes. All right. That's fun. All right. So we're going to use curl. Calypso, I know you said you're new to tech. I don't want to make any assumptions. Have you used the curl command before?
Never.
Okay. Have you heard of curl?
No.
Okay. So curl is your Swiss Army knife of the API world. So a little bit of history lesson on what RESTful APIs are. In the beginning, there was Corba. No, not going to go that far back. But when we started to work with web-based services, web services, in the beginning there was XML, and it was bad. And I love XML for a lot of things, but for web services, it was really bad. Because in order for you as a developer to make an API call, you had to have libraries and parsers, and you had to have generators, and it was a good old mess. And so somebody said, you know what? We're making our lives difficult here. Let's just use what HTTP gives us. So when we call an API, when we call a URL from a browser, that's usually what's called a GET, an action, a method. Actually, is the right word. What method are you using?
Mm-hmm.
Is it a GET? Please give me information. Is it a POST? Here's information. There's also put, delete, and patch. Okay, so that kind of sounds a lot like retrieve data, create data, update data, and delete data, also known as CRUD. Create, read, update, delete. Okay, so we have the basics now of being able to. Marino, you're putting them down a bad dark path. I can't follow you that way. You're trying to give people nightmares here. This is a kid-friendly show, damn it. So REST was thought up as this idea to say, let's simplify web services, the piggyback of what HTTP already gives us. And in the original web services, RESTful services, it was still based off of XML in the early days. But instead of having to have complex programming libraries to even just do something simple, okay, they said, okay, well, we're just going to make it so that it's easy. And so that's where RESTful came in. And REST is actually an acronym, and I don't remember what it stands for off the top of my head. But the idea is that I, as an API developer, should be able to test out APIs without having programming libraries. So curl is the universal web requester that's not a browser, right? And it's got a bazillion options that you can use. We're going to use like the most simplest form. I'm showing it off on my Mac here. It'll be similar syntax on Linux. There is a curl for Windows and PowerShell. It's not made by the same people who make curl, and didn't they have to like rename it or something? There was some controversy around that, but the point is that when you look at examples that are not programming language specific, this is what you're going to see is curl. So let's start simple. So I'm going to go ahead and grab our token. Okay, so curl URL. This is about as easy as it gets, right? And this is the same thing as you get with the browser, right? Same thing, just spit out to my console. We're going to add -verbose, -v, so we can see a little more what's going on. So this is all the information that is going from my curl client off to the API, in this case, to get a token. There's no authentication here, but certificate information, this is the information. So this is the method get that we were talking about, being able to do different things. This is the path that we're getting. This is what we'll accept. So then we get this thing called a 200. So just as the request has a bunch of additional data that the browser doesn't show you, the response has the same information that the browser doesn't show you. So the first thing is, what's the response code? And 200 generally means everything was successful. 500 means that there was a problem on the server side. What's the is 418. If you get 418, it means you're a teapot. So, and I'm not kidding. There is an actual response. Huh?
And then there's 400 as well at the bad request.
Yeah. The different codes mean different things.
Mm-hmm.
For the most part, 200, it worked correctly. 404, not found. 500, there was a problem. 400, there was a problem with the way you formatted your request. 401, 403, you're not allowed to do this. And yes, there'll be a quiz. I hope you're writing these down. These are all written down. And then, like I said, if you get back to 418, it means you're dealing with the teapot. So that'll give you that information. It'll also give you additional headers, additional data that maybe doesn't go in the response, and then you get the data back. So this is text plain. So this is a great example of a badly developed API. This is not text plain. This is JSON. So the API should be telling you this is JSON. So that's the upside to RESTful APIs is they're really easy and flexible to work with. The downside is they're really easy and flexible to screw up. So we get our token. You still haven't used it, right? I'm torturing it. So let's go ahead and actually call a movie. And we're going to do, what happens if I do like get movies, genre sci-fi? Let's just try that. I don't know what the genres are. Let's see here. So what happens if I do this? Genre equals sci-fi. Okay, so the first problem, right? No auth token. So I was saying how 401 means you're not authorized or you're not authenticated. Usually 401 means I don't know who you are. I can't validate your token or you didn't give me one. 403 is I accepted your token, but you ain't doing it. You're not allowed. So you no soup for you. So let's grab a token and try this out. So this was our token. Now, I do not like pasting tokens directly into a single command line because it gets nasty real quick. So what I'm saying here is I'm going to assign my Unix environment variable token the value of the output of this command. So this $ open brace, close brace says, take the output of this and assign it to this variable. So I'm going to look here. So I have the token now there. Except we have a problem with this. Our token is not the whole thing. It's just the thing in the quotation marks. So we don't want to send everything downstream. We only want to send the part that starts with an E and ends with an M. So we're going to adjust this a bit. And I will explain what I'm doing here once I'm done typing. Okay, cool. So this is our command here, and we're doing something called piping. So especially in the Unix world, this is very popular. I think you do it. You say, I'm going to take the output of one thing and use it as the input for the next thing. So if you think about like an actual pipe that water flows through, each section of the pipe is a different task. And it's taking the output of the first task as the input of the next task. So we're saying, I'm going to take this JSON that's being returned, and I want to extract just this part here. So in the Unix world, there's a command called, or an application called JQ that is to JSON what curl is for RESTful APIs and HTTP requests in Swiss Army knife. So we're saying, take the output of my curl command, which is this big thing, and get just the .token part. So here we're saying, give me just the piece from JSON that is .token. Follow so far?
Mm-hmm.
So that's how I get my token variable. Echo token. So now let's go back to our previous curl command where we wanted to get a movie. So this is where I've been yabbering now for 45 minutes. This is where we actually get to make an API call that's authenticated. So we're going to use our own header, the header called the authorization header. And we're going to use a bearer token. We're going to include our token. So now, if everything was done correctly, what should happen is when I hit enter, it's going to make the call with the token as the authorization header.
Mm-hmm.
The relying party, our API, is going to parse and say, yep, this is good. You're authorized, and then actually run whatever the request was. Look at that. We got lots of data.
Yeah.
We got lots of data. Lots and lots. So there's a lot of sci-fi. So let's see if we can look at the get here. Here. So this is the magic. This is where the magic happens, is this authorization header. So authorization, you're telling your relying party, hey, I'm calling this API and it's an authenticated request.
Mm-hmm.
Bearer, I'm using a bearer token. Because there are different kinds of token. If you're working in the Windows world, once upon a time, this might say NTLM, for SSO. So, once upon a time, still upon a time, but it's a different mechanism. You would log into your Windows workstation at the office, and you would never put in another password again. It all just magically worked. That's because your web browser would say, oh, you're logged in as Mark. I'm going to put your NTLM token in. And Microsoft Apps just magically did all work. Kerberos, right? It would say GSS API. So Kerberos is the more advanced version of that desktop single sign-on. So there are different types of bearers of tokens. The vast majority of the time, you as a developer are going to use bearer as your token type. And then you're just putting it in there, right? Like there's nothing special there. That's just our token. And then this is the response back from oops. No, go away. Am I still there? Can you all still hear me?
Mhm.
Okay, cool. So this is all the fun stuff, right? And this is where you start to have the real fun of JQ-R, and you can start to manipulate. But what's important about this? So like you got westerns, you got war, you got thrillers, sports. So lots of movies in the statement. So the important point here is that you're able to test out what the API does without actually having to write any code.
Mm.
You can get that part worked out. Then you can go through the joy of getting it integrated with whatever framework you're working on. Generally, when we got our token, right? We got our token here. We didn't authenticate to get it, right? Like it just gave it to us. But if you think about it, there's a chicken and egg problem here, right? Because how do I know that you're Calypso to give you that token?
Mhm.
And so generally when you get a token, you're doing it based off of something else. It might be off of a username and password. It might be off of a different identity. So if you start talking about like the cloud world, you might say, oh, I'm going to take my the identity for my cloud server and use that to get an identity for this web server. So it'll vary, right? Like yes, it gets very complicated. Like experts will get confused about this stuff. It's super easy to get confused about. I do it all the time. I get called out like, dude, that's wrong. I'm like, I know you're right. And I've been doing this for 30 years. So this is a confusing system. And the scary thing is it's a lot easier than it used to be. But that's kind of your life cycle, right? Of how you go from I authenticate, I use something that authenticates me to get a token. I get that token. I embed in my HTTP request. I get a response. I'm not going to get into it here, but we talk, or the details of it. But when you're writing a web application, especially, that expiration time, when that expires, you need to get a new token. So you either re-authenticate to get a new token. There's a refresh process, that you as a developer might or might not need to know. A similar tip to the relying party side, where I said never ever write your own API management validation. Try not to write your own API management on the client side. Almost every language and framework out there has a way to say, hey, just give us the initial information we need and we'll get the APIs. We'll get those tokens for you. We'll keep it up to date for you. You don't have to worry yourself about that. because quite frankly, it's really easy to screw up. And while the security issue is probably less on the client side than the server side, it's still easy to break. So let the API, let the frameworks do the work for you. So I've thrown a lot at you in the last 50 minutes. You retained all of it, right? So
Yeah, I'm ready for the quiz.
So anything else that you know, I know I throw a lot at you, so it's a little unfair to say, do you have any questions? But you know, are there other things you're curious about or you'd like to see, or maybe I could do a little more in-depth explaining?
I don't know. Like I've never used
That's
curl or Unix or any of this stuff, so like that's super new to me, but I like kind of know what headers are. Because I've done like simple API calls where you didn't need tokens. So like I did see headers, but I don't think I've ever actually used them in calls before. So yeah, but this was actually kind of helpful, like because I can kind of think how it'll work in because I'm using like JavaScript and Node to like
Okay.
build it. Yeah, so it's like not too different from like what you said to do here. So I can maybe figure it out now.
Yeah, and you know, like I said, the at least personally for me, everybody learns differently, everybody does
Mhm.
differently. From my standpoint, what I will generally do is I will start with curl or a similar tool. Or the browser has a lot, you know, there are a lot of great browser plugins
Mhm.
for web developers. Um,
A lot of people
is Tamper.
mention Postman to use Postman.
Postman is super
Yeah.
popular. Tamper is one that is more for web apps that lets you manipulate the request before it goes out.
Mm.
But that one's also super popular. The developer tools that I was showing before, that's in every browser.
Mhm.
Yeah.
So that lets you see the back and forth. That's a mainstay for me. And like I said, curl is like one of the like curl JQ are just the you know the nunchucks, the Swiss Army knife, the Leatherman tool of
Nice.
API development.
But yeah, this has been like a great stream. Like it's a good starting point for a lot of new developers who are new to APIs and
Mhm.
the stuff we did. So, and Mark, you like beautifully explained the in depth of like the payhole and headers because I worked with tokens before, but I didn't really went into the depth of like what each payhole header stand for. So that was like very new for me as well, knowing everything in bit detail. And then I hope that Calypso got like a lot of her questions and queries answered by our Mark. So it was a great stream, and thank you so much, Calypso, Mark, and Marino for your presence. And yeah, so have a and for the folks who have joined us and asked their questions, have a great day, evening, and yeah, Mark, any final thoughts on Calypso before we wrap up?
No, thanks for giving me a chance to talk for an hour. I love talking.
Yeah, thanks for all the help. It was great.
Yeah, this was fun. Like, thanks for doing that tweet, and this like stream came into picture because of that tweet. So we as a community helping all each other. It's fun. So jumping into and learning while on the stream. So it's a great way. So okay, yeah, then we can just end the stream then. Bye.
Happy Friday.
Bye everyone.
Bye.
Bye.